In this video, we're going to talk a little bit more about exponents, specifically these two scary looking ones that we see on the end here, the fractional exponents. We know the definition of 4 squared. That's just 4 times itself. And we know the definition of 4 cubed. That's 4 times itself times another copy of itself. Take 2 of those, or take 3 of those. And here we get 16, here we get 64. But then we get to this, 4 to the power of 1/2. What on earth does that mean? So a lot of guesses that I get from Algebra 1 students is that this means take 4 and multiply it by half of itself. Maybe it's 4 times 2, and that's 8. But that's not how it works. So if you want to find a 1/2 power, then we're going to use this simple definition. A fractional exponent is no more than a square root, or I say square root, but it's no more than just a root. How do I know if it's a square root or a cube root? Well, here, my denominator is 2, and that means that this is a square root, which has, as we know, a little hidden 2 here. So this is the square root of 4, and we know the square root of 4, that's 2. Technically plus or minus 2, right? Well, what about something scary looking like this? 4 to the power of 3 over 2. Well, same idea. Our denominator here is 2, and therefore this is the square root of 4. But on this problem, we have a numerator as well. It's to the power of 3. So where does that go? Well, when you have a fractional exponent, the rule is that the denominator is the root and the numerator is the exponent. So we're going to write this as the square root of 4, but I still have an exponent to write. And so you'll see things like this a lot. The square root of 4 raised to the power of 3. And technically speaking, this can be done in any order. You can say this is 4 to the power of 3 and then find the square root of that. That being said, I think option A, the square root of 4 and then raised to the power of 3 is going to be easier. And that's simply because square roots typically will make numbers smaller, whereas powers make numbers bigger. I know the square root of 4, that's 2, that's easy, and then I can do 2 cubed, that's easy as well. But if I take 4 cubed first, it gets me 64, then I have to find the square root of that, which is fine, but when the numbers get bigger and bigger, what if it's not 4? What if it's, 100? The numbers get bigger and bigger, then finding the square root of that bigger number can be more challenging. And so, generally speaking, I like to do it in this order. And so let's see, the square root of 4, that's something that I know, that's 2. And then 2 cubed. I don't need the parentheses since there's no other operations here. I know that as well. That's 8. So 4 to the power of 3 over 2, that's 8. And that's it. Let's see a couple more examples of this. In our next examples, we have thirds as our denominator here. We have 2 over 3 and 4 over 3. But we're going to use exactly the same rule. The denominator is our root, so this is the cube root of 27, and because it's a cube root, we have to write the little 3. When it's a square root, we don't have to write the 2. And then the numerator is our exponent. So 27 to the power of 2/3 is the cube root of 27, and then squared. 125 to the power of 4/3, well, that also has a denominator of 3. So this is the cube root of 125, and then to the power of 4. So let's do these calculations. The cube root of 27, that's on our list of perfect cubes, so we know that one. That is simply 3. And then, like I said, we could write this with parentheses, but we don't need to. In fact, we would just get rid of them in the next step anyways. So this is 3 squared. And hey, we know the answer to that. That's 9. The cube root of 125. Yeah, we know that too. That's just a definition. This is 5. And now we want to raise it to the power of 4. Well, this is something that we haven't done much of, but we're just going to go back to the definition. This is not 5 times 4. This is take 4 of these and multiply them together. So this is 5 times 5 times 5 times 5. And that's going to give us 625, right? I'll even write it in. There. If I take 4 5s and multiply them together, I get 625. So that's how it works. I think we'll just do like one last little example. For our final example today, we have 256 to the power of 3/4. So this is going to be into some slightly new territory, but I don't want you to be worried. So let's go ahead and give it a try. Our denominator is our root. So this is going to be the 4th root of 256, which might sound scary because we've been sticking with square roots and cube roots, but I think we can do it. And then all of that is going to be raised to the power of 3. So let's check it out. Well, if a square root was what number times itself gives me the number in the radical, and a cube root is what number times itself again gives me the number in the radical, then a 4th root is simply what number times itself again, times itself again gives me that number in the radical. And let's throw out some obvious options. It can't be 1. We could try 2. 2 times itself is 4 times itself again is 8 times itself again is 16. Way too small, so that can't be it. We could try 3, but multiplying odd numbers together always gets you another odd number, so there's no way it could be 3. And we could prove it. 3 times 3 is 9, times 3 again is 27, times 3 again is 81. All odd numbers, like I said, and also not 256, so not even close. So let's move on to the next number, 4. 4 times itself is 16, times itself again is 64, times itself again, that's 256. So the 4th root of 256 is 4, but we still need to find the cube of that. So now that we know the 4th root of 256, 4 cubed, that's something that we should have memorized by now. That's just 4 times 4 times 4, and that is 64. So 256 to the power of 3/4, that is the same as the 4th root of 256, all raised to the power of 3. And that is the same as 4 to the power of 3, because 4 times 4 times 4 times 4 is 256. And then that is the same as 64, because, well, 4 cubed is one that we know. So that's how this process works. Very simple, just a straight up definition. You just have to be able to find squares, and you need to be able to find square roots and cube roots, and maybe some 4th roots, maybe even some 5th roots, and then find the powers of those numbers that you got. So that's it for this video. Thank you for watching. I hope it helped you, and I will see you again next time. Bye-bye.